Now, before starting our object-oriented programming journey in Python, let's discuss about what is the difference between the procedural programming and the object-oriented programming. So you will have the better idea why we use object-oriented programming. Now, traditional programming languages such as C or Pascal were called procedural programming languages or structural programming languages, where the basic unit was functions. Now, programming in these type of procedural languages involves choosing a data structure and then designing the algorithm and then translating that algorithm into a code. So if this sounds a little bit confusing, let me try to explain it with an example. So let's say you have been given a task to create a program for a passenger who wants to travel from one place to the another place using a cab service. So if we think from the point of view of procedural programming, what we do in the procedural programming is we create some global data structure which holds the data. So here, for example, we create some kind of data structure which can hold the data. For example, in case of a cab service, which cab service is it, or which type of cab is it, and at what location this cab is standing. All these kind of data we store in a data structure in a global environment. Now, after storing the data, we design an algorithm. So let's see what kind of algorithm we can develop in the procedural programming language for our cab booking service. So this is a pseudocode which I have written. So first of all, the passenger will open the app from which he can book a cab, and then he will book the cab, and once the cab is booked, he will wait for the cab, and then once cab arrives, he will sit in the cab, and then he will reach to his or her destination, and at the end he will pay the fare of the cab. And this is the pseudocode of that algorithm, and then we will translate this algorithm into actual code in procedural programming language. Now, in these type of procedural programming languages, we concentrate on creating the functions, and the major drawback of using these functions is that data and operations on the data are separated. That means we need a methodology to send this data to these functions. So here we need to send this data which we have saved globally into these functions, and these functions take this data either as argument or as a global variable and then perform some actions on this data and give you some result. Now these kind of functions are passive. What do I mean by passive here? That is, these kind of function cannot hold any information inside them. So once you give the data, they are able to give you the result back after performing some operations, but they cannot save or hold the state or the data, so that if you want to use that data in some other place in your code, then it will be very difficult using these kind of functions which you use in procedural programming. Now let's look at the object-oriented approach of doing things. So in object-oriented programming languages like C++ or Java or Python, the basic unit is class. Now if we take the same example of a passenger who wants to travel from one place to another using a cab service, using object-oriented programming thinking, which depends upon the creation of object, we can create different kind of objects. For example, for a cab, we can create a class called cab, and then we can create a class for cab driver, and the third class we can create for a passenger. Okay, so a class you can create for any real life object. It can be a car, it can be a motorbike, it can be a book or employee or a person. So object oriented programming allows us to create object. So first of all, what is a class? So a class refers to a blueprint in which we can have data and methods. Okay, so for example, for our cab class, what attributes this cab class can have? For example, a cab service, which cab service we want to take. What is the make of the cab? Is it a Toyota or a BMW or a Volkswagen cab? At which location this cab is right now? What is the number plate of that cab so the passenger can recognize this cab? So all these things which I have written here are called data because they can hold some kind of data. Number plate has number plate data, location have geolocation data, make have the make data. Cab service can have data like Uber or any other cab service. And the other thing which a class can have are called method. So earlier we have seen that we can create functions, and when these functions you use inside a class, they are called method. Okay, so functions inside a class are called method. Now the data inside this object or class is called attributes or the member variables which can hold some data. And using this class we can create object of the cab class, which means we can create different object using a same class. And how to create object using classes we will see in the next video in the real life example. So don't worry if you don't understand how these things works. I will give you a real life example so you will be able to understand in a better way. Now what is an object? An object is a software unit that combines data and methods. Okay, so we have this data here and then we have the methods inside the class, and object is able to combine both of them, which is data with the methods. Now these objects, for example a cab object and the passenger object, can exchange the data between them also. So data is interchangeable between, for example, the passenger object and a cab object. So let's rewind once again what we have learned about object-oriented programming. So the basic unit in object-oriented programming is a class, and a class refers to a blueprint which can have the data and methods. Now using a class we can create objects. And what is an object? Object is an instance of a class, and each object can have its own data and method, and an object is able to store the state of some kind. So at which location this cab is right now. So this is a state, and an object is able to store that state. Now in procedural programming, if you remember, there is no relation between the data and the method, right? We need to provide the data to the method, which are separate entities in the procedural programming language. Now these data members are called attributes or member variables, and these functions which you define inside a class are called methods. And what are some of the key differences between procedural programming language and object-oriented programming language? The first is the unit in procedural programming language is function, and on the other hand in object-oriented programming the unit is class. The second is the procedural programming concentrate on creating functions, while object-oriented programming starts from isolating classes and then they can have data and methods inside it. In procedural programming language, the data and the functions are separate, and in object-oriented programming language, data and methods are not separate. They are the part of a single object of a class. Now, if all this seems to be little confusing to you, don't worry, you are not alone, and I will try to solve this confusion in the next video, in which I will tell you how to create the classes and how to use classes in Python. In this video, I'm going to show you how you can create your first class in Python. Now, if you haven't seen my last video in which I have discussed what is object-oriented programming and what are classes, I will highly recommend you to watch that video because this will be a continuation of that video. So let's create a class in Python. So for that, I will create a new project. So let's create a new project in PyCharm. So just click on File here and then click on New Project. And then the project name I'm going to give here is Oops. And then I will just click on Create. And I will choose this option which says Open in Current Window. And also this option which is Add to Currently Opened Project, which is going to create this project in this window itself, which is already open. So now you can see we have an empty project here. And inside this project, let's create a Python file. So right click on the project and then New, and then we are going to create a new file. And let's create a class called car. So I'm going to name the file name as car because we are going to create the car class. Now, in order to create a class in Python, you use a keyword class and then you give the name to your class. So the class name in our case is car, and then you give this colon, and for example I write here a keyword called pass. Now when you write this keyword after the declaration of a class, this means that it is an empty class. You can also use this pass keyword to create an empty method. So this keyword pass is used to create an empty class or an empty method. Now here, after the class declaration, let's see how we can create an instance of a class. So it's really easy to create an instance of a class. So let's create a first object and I'm going to name it as Ford, which is a car brand. And then you use your car class name and use these parentheses here. Okay. So this here, Ford, is an object, or you can also say it's an instance of the class car. In a similar way, we can create multiple objects. For example, Honda is another car brand, and you can create the Honda object using this class car. Once again, you can create a new object, for example, Audi, and then you can once again use this car class to create this object. So what we have done till now, we have created 3 objects from the class car. Now in the previous video, I told you that you can associate some data with your object. So let's associate some data. So for example, Ford, we can associate an attribute called speed, right? So we can assign the speed, for example, 200 here. For Honda, we can assign speed, let's say 220, and for Audi, we can assign the speed, let's say 250. So speed here is called the attribute. And whenever you create an empty class using this pass keyword, you can add these attributes on the fly. So you can see we have added these attributes after the declaration of the class and after the creation of the objects. Let's add some more attribute to these instances or the objects. So a car can have the color. So I'm going to just write color, and the Ford has, let's say, the red color, and let me just copy and paste here, and let's say the Honda have the blue color, and we have the Audi of black color. So once again, color is an attribute here. Now if you want to print these attribute, you can use this print method, and then for example we want to print the speed of Ford and the color of Ford, then we can do it like this. And let's run the code. So in order to run this code, first of all, when you create a new project and a new Python file, you need to right click on this file and then click on run the file name, whatever is your file name. My file name was car. So you can see now the result is printed here. First is the speed and second is the color of an instance Ford. Similarly, you can print the color and speed of your Honda and Audi objects also. Now if you want to change some attribute, it's also possible. So let's say I want to change the speed of Ford object. So I'm going to use Ford dot speed once again, and this time I want to assign 300 speed to this attribute. Let's say we also want to change the color of the Ford object. So I'm going to just use Ford dot color, and this time I want to use the color blue here. And let's once again we will try to print the color and speed of the object Ford, and now you can see this result. So before the speed was 200 and the new speed is 300 for the object Ford, and before the color was red and the new color is blue for this object Ford. Now if you have followed the last video, this speed and color is the data. So speed and color are the variables which holds some data inside them. But still we haven't added any behavior or methods to our class car, and that we will do in the next video. Now let's create a new class, because understanding classes in any language is difficult. So let me give you another example. So this time I'm going to create a new Python class, and I'm going to name this Python class as a rectangle, and then press OK, which is going to create this class. And to create a class, you already know, you use the keyword and the name of the class and then the colon, and we will also make this class an empty class using this pass keyword. And in order to create an instance, I'm going to just write rect1, which is the first object, using the rectangle class, and then I'm going to create rect2, which is the second object, using this rectangle class. And now what are the attributes which we can relate to the rectangle? A rectangle have a width and the height, so let's add the width and height. So let me use the first object, and let's say height is 20 for the rectangle 1, and then we are going to use the second object, and once again we are going to add the height for the second rectangle. Let's say the height of second rectangle is 30. Similarly, we can add the width to the rectangle. So width is equal to, let's say it's 40, and rect2 object have the width, let's say 10. So what we have done here, we have created a rectangle class, and then we have created two instances of the rectangle class, rect1 and rect2, which are also called objects. And then we have added some attributes to our objects, which are height and width. Now let's say you want to calculate the area of these two rectangles. I can use the print method, and then what is the area of the rectangle? It's the multiplication of the height and the width, right? So I can use this rectangle 1 object, and then I can call the height and width of this object, and this will give me the area of the rectangle 1 using this multiplication operator. Similarly, I will do the same for the object 2 here, and let's run the code. And if you remember what we need to do, if we create a new Python file, we need to right click on the file and then click on run, right? So once the file is running, you can choose from here which file you want to run, but at least once you need to right click on the file and just click on run whatever file name you have. So you can see the area of rectangle 1 is 800 and the area of rectangle 2 is 300. So this is how you can create a very simple class in Python. In the next video, I'm going to show you how to add behaviors to your class. That means how to add methods to your class and how to use this method to manipulate this data which we have provided here in the form of attributes. In this video, I'm going to show you how to use init method in Python and how to use a keyword called self in Python. So I will continue with the class which I have created in the last video, and this was the class which we have created, and we have used this special keyword pass there. And pass we were using to create an empty class. Now I'm going to remove this pass and I'm going to add a method called init here. So I'm going to just write def and then underscore underscore init and then press enter, and you can see this init method is created here. So this is like a normal method with double underscore in front and back of this init keyword, and you will also see the self keyword is already added as the first argument of this method. Now this init method serves as a constructor for the class. So usually it is used to initialize some attributes or some functions, because this is the first method which will be called when you create an instance of a class. So here we are creating an instance of a class, and this init method will be the first method which will be called when this object or instance will be created. So let's check what I'm saying. So let's say I want to print inside this init method that the underscore underscore init underscore underscore is called. And let me run this code. So I will change this to car and then run this code. And now when I see this result, you will see this line is called 3 times because we have created 3 instances from the same class. Okay, so every time this instance is created, this print is called, and that's why this line is printed 3 times, and everything else will be printed after that. Whatever we were printing, for example, speed or color of the car, will be printed after that. Now one important thing to notice here is I said init serves as a constructor. It's not a constructor. Although it would be tempting to call this init method as a constructor, actually it's not a constructor, but it behaves like a constructor because init is the closest thing we are going to get in Python to a constructor, because it is the first method which is called whenever an instance is created. Now if you are familiar with other object-oriented programming languages like Java and C++, there is a destructor also in those kind of languages with classes. Now Python doesn't have any destructor because Python has an automatic garbage collection. So you don't need a destructor in Python because Python will take care of anything which should be taken care of. Now as I said, usually init method is used to initialize something. So instead of initializing the value of speed and initializing the value of color, let me just comment this code first of all. So I'm going to select whatever I want to comment, and then I can press Control / to comment all the line. You can also go to code and then use this option which says comment with line comment, and you can see the shortcut for that, Control +/. Okay, so this is going to comment your lines of code. And now I want to use the speed as the initialization value. So after this self keyword, I can give the next parameter which is speed here, and then the third parameter is the color here. And now to print the value of speed and color, I can use once again print, and then first of all I'm going to print the speed, and then I'm going to print the color attribute. And as soon as you do this, and when you try to run this program, it will give you an error. So let me run the program and it will give me the error. It says init missing two required positional argument, which is speed and color. Okay, so once you create an init method and provide any arguments other than self is automatically provided by Python whenever you create an instance of a class. But other than self, when you write for example speed and color arguments here, you need to provide those arguments at the initialization of your class. So here first we will give the speed inside these parentheses, for example 200, and then the color, for example red here. Okay, same we need to do for the other two instantiation of the car class. So let me do it for the second instance and also for the third instance. And now let's run the code once again and let's see what happens. So now you can see everything works fine and no error is given to us. And you will also see, because this print is called first, you can see the speed is printed first and then the color, and then this line is printed after that. And that means we will get the speed, color and this line 3 times for every instance with different values, whatever values you have provided for the instantiation of your car class. Now usually you provide these arguments because you want to initialize the value of speed. So let's try to access the value of the Ford object speed and color. So let me just uncomment this code and let's run this code, and it will give us an error. You can see this says that car object has no attribute called speed, right? So what is the error? Because we have provided these attributes speed and color, but we haven't assigned these values to any attribute inside this car class. Earlier what we have done is we have assigned the speed value to a speed attribute and the color value to the color attribute, but we have already commented those codes. So how can we assign the speed and color to the car object? So it turns out that you can use the self keyword, and then using the self keyword you can assign the value to the current object. So self is essentially the current object. Okay, it's similar to using this in C++ or Java if you are familiar with those two languages. So you use self dot and then the name of the attribute, for example speed in our case is equal to whatever argument you provide for speed. So we have provided the same argument, which is speed itself. Once again I can use self to set the value of color here. So self dot color is equal to color. Let me remove this semicolon because it's not required. And now when I run this code, you will see that there is no error now. So because we have now used the self keyword to set the attributes of speed and color, so we can easily access the values of the speed and color using any object of the car class. So let me once again minimize this. So now let's talk about the self keyword here. So whenever you create a class, the first argument of every method you need to provide this keyword self. Now it's not necessary to provide this same keyword which is self, but it's a convention to write this self as the first parameter. The first parameter can be, for example, ABC. It doesn't matter, but you need to use this ABC here also as self and it will be totally fine. But it's a convention that we use this self keyword in order to indicate that this is the current object. So every method you will create, you need to give this self keyword as the first argument of your method inside a class. Now you may also observe that here when I am initializing this class instance, I'm not providing any self keyword. So even though in the init method I have provided 3 arguments, I'm only providing 2 arguments here. So it turns out that you don't need to provide the first argument, which is self. It will be automatically be provided to your class. So you just need to give the next argument, whatever argument you give after the self. So we have given speed and color after the self argument, so we just need to provide those arguments after whatever you use after this keyword called self. So let's do the same thing with our second class, which is the rectangle class. And here also we have created this empty class. So let's remove this pass keyword, and instead of this pass keyword we will use this init method, which is def underscore underscore init underscore underscore. And here after the self we will provide the height as the second argument and the width as the third argument. Okay, and then we are going to initialize the attributes height and width using this self keyword. So self dot height is equal to height, self dot width is equal to width. Okay, so this is how you can initialize your attribute using this init method. And now when you do this, you don't need to initialize these values like this. You can directly initialize this height and width using these parentheses. So let me provide these values. Let's say 20 and 60 for the first rectangle, and let's say 50 and 40 for the second rectangle. And when we run this code, let me just change the file here and then run the code, and you will see it will print the area once again here. So this init method is used to initialize your attributes or whatever you want to initialize at the start of your class. You will do all those initializations inside this init method. In the last video, we have seen how to use init method and self keyword in Python. In this video also, we will discuss more about init method and the self keyword. So let's get started. So here I have a very simple class called hello, and in this class I have a method called init, and I'm just instantiating this class and creating an object out of this hello class. Now the first question which may arise is, what if I don't want to use this self keyword? You can see directly that there is a red squiggly line appears here, which means an error, and this we can also see when we run the program. So when we run the program, it's going to give us this error which says init takes 0 arguments but given 1. Now you may ask why it's saying that we have given 1 argument to the initialization of this hello class. So as I said in the last video, that self is automatically passed when you initialize a class, and that's why it says that 1 argument is given but init takes 0 argument, because here we haven't given any argument inside these parentheses. So self is absolutely important, so you need to give the self. Now the second question you may ask is, can I create multiple init method inside a class? So let's see if it's possible or not. So here I'm going to give this pass keyword, which means that this init method is an empty method, and let me create a second init method, and this time I want to add one more parameter here. Let's say name. Okay, so we have provided 2 init methods here, and let's see what happens. So this is the instantiation of class where I haven't given any argument to this instantiation. So I'm going to run the program, and what it says init missing 1 required positional argument, which is name. So it turns out that it's not possible to provide multiple init methods in your Python class. if you provide multiple init method in your Python class, the init method which you define at last will be considered as the main init method and other will be overwritten. Okay, so whatever init method you define at last, that signature of init method will be valid, and all the other init method which you will create will be overwritten by the last init method. Okay, so let's provide the argument name here. So I'm going to just provide one argument here and then run this code, and it works perfectly fine. Okay, let me just reverse this order. So instead of using this init at the top, I will use the init which doesn't take any parameter at the bottom now. Okay, and we provide this argument, and let's run the code. And now once again we get the error which says init takes one positional argument but two were provided. So one positional argument means that this init only takes the self argument and nothing else, but here self is provided automatically, but we are providing an extra parameter here which is not required, and that means this init which we have defined later is valid and this previous init is not valid. So always remember, it's not allowed to use multiple init method in the Python class, but if you do this, the last init method will be a valid init method and all the other init method will be the invalid init method. Now one more question you may ask here, what if I want to create both kind of instances, one which takes no argument here and other which takes one argument or multiple arguments here? So the answer is in my previous video, in which I have shown you how to provide default value to your arguments. So let's say I provide a default value to my argument here. Now I will create two instances of the same class. One takes no argument and other takes one argument, and when I run this code, no error appears here. Okay, so if you want to create an init method with multiple parameters, you can either use this default value for your init method parameters, or what you can do here is you can use this parameter which takes a tuple. So in the previous video we have seen that we can provide an argument with asterisk in front of it, and this means that we can provide multiple parameters to our method here, and when we run the code, it's also valid. We can also provide multiple parameters here and it will also be totally valid. So I'm going to run the program once again and you can see it's totally valid. So if you want to provide multiple parameters to your init method, you can use this kind of notation, or you can provide the default value to your parameter, or the last thing you can use is you can use, for example, this type of argument which takes the keyword, so kw args here. Okay, and this also we have seen whenever you use this kind of notation, that means you want to provide the dictionary, right, key value pair. So let me provide some kind of key value pair. Let's say name is equal to some kind of name here, and then let me run the code and it's totally valid. It doesn't give us any error. So even though multiple init methods are not allowed in Python, you can use these type of notations in order to give variable length argument in your init method. Now let me just remove all the parameters from here and this instantiation from here also, and let's take the next question. So let's say I want to remove this pass keyword from here, and here I want to initialize some values. So self dot name is equal to, let's say we will provide some name, so I'm going to provide a argument called name, and self dot name is equal to name here, and then let's say self dot age here, and we provide some value which is not taken from the argument, but we provide some static value here. Is it allowed? Yes, it's totally allowed, right? So if you want to provide some default value for your attribute, you can absolutely provide that without even passing it as an argument. So it's not necessary that all the attribute values you need to provide from this argument list. You can provide any default or static value here which is not coming as an argument. So I hope that clarifies some more details about this init method. In this video, we will learn how to use encapsulation in Python. Encapsulation is one of the most important principles in object-oriented programming. So let's get started. I will be using this car class and the rectangle class, which we have been using in the previous videos also. And let me remove these print statements because we don't want them right now. Now let's say we want to change the value of speed. So if you want to change the value of speed, you can simply take your object, for example Ford dot your attribute name, for example speed, and then you can directly change it, for example 300, and when I run the program, it's going to print the new speed, which is 300. Initially we have set the speed to 200. In here we can also put, let's say, the speed as string, which is very stupid, but will it work? It works, you can see here. And this can break the function in which the speed is used. So therefore it is very important that we protect our data and only give the access to our data to the other users. So encapsulation is particularly important when you want to give your code to some other people because they might want to change your code. So let's see how we can encapsulate our code. So to encapsulate our code, we create functions. So let's create a first function, which is to set the value of speed. So I'm going to just say set underscore speed, and inside the parentheses it's going to take self as the first argument, which is the default, and second is the value of speed. So I can say value here, right? And then once we have the value of speed, we can just call self dot speed is equal to value. Similarly, we can create a get method for the speed. So right now we have created the set method to set the speed, and now we are going to create a get method to get the speed. And in order to get this speed, we don't need to pass any argument. We just need to return this speed, which is already set. So we can just write return and then self dot speed. So we have created two functions, set and get. These are also called setter and getter for the attribute, which is speed in our case. So let's use these functions instead of this kind of setting of data. So first of all, I'm going to call this Ford object dot set speed method out of this object, and then I'm going to pass the new speed using this set method. Now in order to get this speed, I can write, instead of this Ford dot speed, I can just write Ford dot get speed, which is going to give me the speed of this Ford object. So I'm going to run the code, and you can see it prints the speed which we have set using the set method. But still, will this protect your data? Let's see. So I'm going to once again try to use Ford dot speed, and then I will try to set the new value of speed. Will it be a problem? No. So you can see when I try to get the speed, the new speed is set, and we want to prevent this kind of setting of data using this equals to symbol. So we need to somehow make our attribute private. Now if you are familiar with other object-oriented programming languages like Java or C++, they use the keywords like public, private or protected in order to mark their attributes or the member variables as the private or public or protected. But Python doesn't have any of these keywords. So how we can make our data private? So let me give you first of all an example. So I'm going to go to this class, which is hello, and here I'm going to set some values. So first value is, for example, self dot a is equal to 10. Second value is self dot underscore b is equal to 20. And the third value is self dot underscore c is equal to 30. So we have created three member variables in this hello class. One is a, second is underscore b, and c is with two underscores in front of it. And let's try to access all these three values. So I'm going to just use the print method and then the hello object dot a, and similarly I will use this print to get the value of dot underscore b and also dot underscore c. And let's try to run this program and let's see what happens. And you can see here the first value which is printed here is 10, which is the value inside the a variable. So this code was executed successfully. Now we can see here that 20 is also printed. That means this code is also executed successfully. But at the time of underscore c, when we want to use this underscore c outside the class, it says hello object has no attribute called underscore c. And this is the point. So underscore you can use to make your attribute private. Okay, so this is a convention. There is no keywords like private in Python. That's why Python uses this kind of convention in which whenever you use double underscores, it makes your data private. When you use single underscore, that also means that it's a private variable, but this is only a convention. Nothing stops you to change the value of underscore b or accessing the value of underscore b. Okay, so if you truly want to make your data private, then use double underscore in front of your variable. When you use single underscore, that means it's a partially private variable and it's only a convention. Okay, so let's go to our car class once again. And now we know that we can add double underscore in front of our variable name. So we have two variables here. One is speed. So let's add double underscore in front of speed. And also let's add double underscore in front of this color variable to make both of them private. So I'm going to change this value of speed in getter and setter also. And now let's try to access this value using this Ford object, which is underscore speed. Now let's try to run our program. So I'm going to change the file and then run our program, and you will see that it's going to give us an error. And this error says the car object has no attribute called color, because this variable color is private now. Also, you will observe that the value of the speed is 300, which is set by this set function. Even though we have set the speed again to 400 using this underscore speed, but this speed is not changed, right? So we cannot change the speed using this underscore variable, because now it's a private variable, and that means we cannot change the value using this variable. We need to use this set function in order to change the value of the speed. Also, if you want to use this underscore color here, and let's run the code, this will also give you an error because this underscore color is private. So either you can remove this code, or you can create the setter and getter method for the color also. So let's create the setter and getter method for the color. And now we can access the value of color using the get color method, right? So instead of this get speed, we can just write Ford.get color, and it's going to give us the value of color. And now you can see that there is no error, and the speed here is 300, which we have set using this set speed method, and the color is red, which is the color we have given using this argument in the constructor. And this type of restricting your data access using functions is called encapsulation. Let's do the same thing with our rectangle class also, and let's create the setter and getter method inside the rectangle class. So you already know we can use this define, and then we can first of all set, for example, set the height first of all, and then we can give the value of height here, and then self dot height is equal to height, right? And don't forget, you need to give double underscore in front of your attributes in order to make them private. So I'm going to do just that, and let's create the get height method also. So now we have created the setter and getter for the height, and let's do the same for the width also. So now you have made the height and width as private, and we have created setter and getter for the height and width. And now in order to calculate the area, we can define one more method here, which is the area method. So let's create the area method here, and this area method is not going to take any argument. We are just going to return the multiplication of the height. So self dot height multiplied by self dot underscore underscore width, okay, which will give us the area of this rectangle. And we can call this area method instead of using this kind of notation. So rect1 dot area and rect2 dot area also. And let's run the code by changing the file name here and run this code, and you can see the area is printed now. So this is how you can use encapsulation in Python to hide your data. In the last video, we have seen how to use encapsulation in Python. And we have also seen how we can declare private member variables in Python. To declare a private member variable, we use double underscore in front of your variable name, and this variable becomes private. But the question is, what exactly is a private member variable? So a private member variable is private to the class. That means you can use this private member variable inside the class, but as soon as you use it or access it outside the class, it will give you an error. So you cannot access a private member variable outside a class. And the example we have already seen. So here you can see I try to access this private member variable outside the class, and when I run the code, it says that there is no underscore underscore c attribute for this hello object. Why? Because whenever you create an instance, and if the member variable is private, this private member variable is invisible to your object. So you cannot access the private member variable outside the class. But can we use this private member variable inside the class? Let's see. So I'm going to declare one more method here, and I'm going to name it as public underscore method, and this doesn't take any argument. But what we have learned about the methods in a class, that even though you don't pass any argument to the method, you have to provide at least one argument, which is the self argument. And what is self? Self is the current object. So let me just print something here quickly. For example, public here. So can we use this private member variable inside this method? Let's see. So I'm going to just write self dot underscore underscore c, and then I'm going to run this code. And let me comment this line because this was giving us an error, and instead we can use this public method. So I can use an instance of hello, which is hello dot public method, and let's run the code now. And you can see there is no error. That means you can use your private member variables inside the class or any method of the class. Now the other question is, what is a public member variable like A here? So A is a public member variable because it doesn't contain any underscore underscore in front of it, and that means you can use this public member variable inside the class as well as outside the class. So if I want to use this public member variable inside the class also, I can just use self.a and then run the code, and it's totally fine. It doesn't give us any error. Let's print the value of those two member variables and once again run the code, and it will print the value of A and C, and then this message which we are printing here, which is public here. Now the next question is how we can define a private method in the class. So let's see how we can define a private method. You already know most probably, which is by using double underscore in front of your method name. So for example, underscore underscore private underscore method, and then I'm going to just print something inside this method. Let's say private. So this is a private method, and how you can define a private method using these double underscore in front of the name of your private method, and the restriction will be the same on the private methods also. So let's try to access this private method outside the class. So I have this hello instance, and when I press dot here, you will see there is no suggestion for this private method because PyCharm already know that this is a private method, so it doesn't show this method in the suggestion when you use this object outside the class. But let's try the brute force and let's try to use this method outside the class, and when I run this code, you will see once again you will get an error which says hello object has no attribute underscore underscore private method. So private methods also you cannot use outside the class, but inside the class absolutely you can use your private methods. So how to use your private methods inside the class? So you can use your private method inside the class using once again a self keyword. So you write self dot and then your method name, for example private method, and that's how you can call your private method inside the class using self. So any method you want to call inside a class, you do it once again using this self keyword as you do with your member variable. And once again when I run the code, now it prints private using this statement, and this statement is executed when we call this private method from here. So I hope this video will clarify some more doubts about the private member variables and private methods in Python. In this video, we will talk about Python inheritance. So first of all, what is inheritance in Python? So classes in Python can be extended, creating new classes which retains the characteristics of a base class. And this process is known as inheritance. Now in simple words, the idea behind inheritance is that a new class can borrow the behaviors and methods from the another class. Now the inheritance involves two types of classes. One is a superclass and other is a subclass. Now the subclass inherit members of the superclass on top of which it can add its own members, for example any other member methods or variables. So here subclass is the one who is doing the borrowing of the members, and the superclass is one from which subclasses borrows these kind of member methods and variables. Now if this inheritance sounds to be a little bit confusing to you, let me give you an example. So I said in inheritance there are two types of classes. One is a superclass and other is a subclass. Now in this example, I have taken polygon as a superclass and two classes, rectangle and triangle, as the subclasses. Now if you see carefully, what is the relationship between rectangle and polygon and triangle and polygon? So rectangle is a polygon, right? And a triangle is also a polygon. That means the rectangle can inherit some properties from the polygon class. Also, triangle can inherit some properties from the polygon class. And the relationship between the superclass and the subclass is defined by a relationship called is-are relationship. So rectangle is a polygon and triangle is a polygon also. That means that rectangle and triangle can inherit from the polygon class. So in inheritance, the subclasses have a is-are relationship with the superclasses. So let me give you one more example. So as a superclass, you can take an animal class, and then as subclasses you can create a dog class, cat class, rat class, because all of them are animals. So dog is an animal, cat is an animal, rat is an animal. So always remember, when you use inheritance, there is a is-are relationship between superclass and the subclass. Now let's take a real life example and let me try to explain you this concept with some code. So I'm going to create a new project in my PyCharm IDE, and this I'm going to name it as inheritance, and I will choose this option, open in current window, and also this option which says add to the current opened project, which is going to create the project in the same window. So now this project is created. So I'm going to go inside this project and I'm going to create a new Python file here, and I'm going to name this file as polygon, because we are going to create a polygon class. And inside this polygon.py file, let's first create a class called polygon, and inside this polygon class, what are the attributes which we want to add here? So rectangle and triangle, what are the common things which they both have? They both have the width and the height. So we are going to first of all create a variable called width, and we will initialize it by a value none. The none keyword is used whenever you want to assign nothing to your variables, right? In the same way, I'm going to use height and I'm going to assign none to that also. Now what I'm going to do is I'm going to create a method here. So let me define a method using def, and I'm going to use this method to set the values of width and heights. And this method is going to take two arguments. One is the width and the other is the height, right? Now if you remember, in the last video I have shown you how to make your variable private. So you use double underscore in front of your variables to make them private. So I'm going to add this double underscore in front of width and height. That means these two variables are private. Now using this set values method, I'm going to just set the values of the height and width. So self dot underscore underscore width is equal to width, and self dot underscore underscore height is equal to height. So this is the polygon class which we have created, and it's a super class in our case, right? And now let's define two subclasses. One is a rectangle and other is a triangle. So let's define other class called rectangle, and inside this rectangle I'm going to define one method. Let's say this method is a area method, and this area method is going to give us the area of the rectangle. And what is the area of the rectangle? The area of the rectangle is the multiplication of the width and the height. Similarly, I'm going to define a triangle class also. So let me define the triangle class here. And let's say this triangle class also have this method which is area. Now what is the area of a triangle? The area of the triangle is the multiplication of width and height divided by 2. So we are going to divide the multiplication of width and height by 2. This is the area of the triangle. So now we have defined 3 different classes, and we are saying that polygon is the superclass and rectangle and triangle is our subclasses. Now how we can inherit the properties of the superclass, which is polygon, into our subclasses, which is rectangle and triangle. So in order to inherit from one class to another, you use this parenthesis, and inside the parenthesis you write the name of your superclass, and that means your rectangle is inheriting from the polygon class. Similarly, when we write this parenthesis and the polygon class here, that means triangle is inheriting from the polygon class. Now when a subclass inherits from a superclass, the superclass member variables and methods are accessible also using the subclass also. So let me give you an example. So I'm going to create the instance of rectangle first of all. So let me just write rectangle. So this is the rectangle instance, and let's create a triangle instance also. And now once we have triangle and rectangle instance, let's use this rectangle instance, and when you write dot here, you can see IntelliSense says that area is available for this object and set value is available for this object. So when you use set value, you can see we haven't defined the set value method inside the rectangle, but because we are inheriting from the polygon class into a rectangle class, all the members of the polygon class are available using the rectangle object also. And what this method takes, it takes the width and height. So we are going to provide the width and let's say height 50 and 40, and once again we are going to use the triangle object and we use the set values, and this time also let's say I'm going to provide the same values here. And what does this set value method is doing? It's just setting the values of width and height inside the polygon class. Now in order to calculate the area, we can call the area method from the rectangle and the triangle class. So let's just do that, and I'm going to do this inside a print method, and I'm going to just call the rectangle object dot area, which doesn't take any argument, and same I'm going to do for the triangle object also. So triangle dot area. So what do you think will happen now? So let's run the code and let's see what will happen. So I'm going to right click on this file and I'm going to just choose run a polygon, and it's going to run the program, and you will see it gives us an error. And what is the error? The rectangle object has no attribute rectangle underscore underscore width. That means because this width and height are private member variables of the polygon class, they are not accessible from the subclass, which is the rectangle class and the triangle class. So you cannot inherit the private members from the superclass into the subclass. So what is the solution here? So what we can do here is we can create the getter methods for the width and the height. So I'm going to do exactly that. So let's define a method called def get underscore width, and it's going to take no argument, and it's going to return the value of the width. So using self, we can access the value of underscore underscore width. In the same way, we can define a method called get underscore height here, and it's also not going to take any argument, but we are going to return the value of the height here. So self dot underscore height. So now we have created the getter methods for the width and height, and these getter methods are the public members. Why they are public? Because we haven't used the double underscore in front of these two methods, and these two methods now we can use in place of these private member variables which we were trying to inherit in the subclass using the superclass. So instead of underscore width, we can write self dot get width, and also here instead of underscore height, we can use get height. Similarly, we will do the same for the triangle class. So get width and the get height dot get height. Now let's run the program again and let's see what happens. And now when I run the code, it gives me the area of rectangle using this print line statement, and then it's going to give me the area of triangle, which is exactly the half, using this line of statement. So let me once again minimize this and let's recap what we have learned. So we have created a superclass and two subclasses. Superclass is polygon and subclasses are rectangle and triangle. And in order to inherit from the superclass, you just use parentheses and the name of your superclass. And that means in our example, rectangle is inheriting from the polygon class. Next, what we have learned is all the public member variables or the methods are accessible from the subclass from the superclass. So set value method and get value method is accessible because they are public methods, but underscore width and underscore height are not accessible because they are the private member variables. So you cannot inherit the private member variables into your subclasses. Now we have seen this example in which we have created two instances of the classes. One is rectangle object from the rectangle class and the other is triangle object from the triangle class. And first of all, we have used the set method, which is coming from the polygon class. It's not the part of the rectangle or the triangle class, to set the values of width and height. And then we have just called the area method from these two classes in order to give us the area. So this set method is used to set the value. So it has set the value of width and height, and using this get method, get width and get height, this value is returned and this value is returned into the subclasses, and then the multiplication of these two values gives us the area here, and the multiplication of these values divided by 2 gives the area of the triangle here. So this is how you can use inheritance in Python. In this video, we will discuss how to create modules in Python. Now, in the previous videos, I have already discussed briefly about built-in modules and how to import a built-in module. You use an import keyword and then you use the name of the built-in module in Python. Built-in means this module is already present in Python. So we can use these built-in module in order to perform some functionality. So for example, this math module helps us to perform some mathematical operations. Now, first of all, what is a module? So it turns out that a module is nothing but a Python file. Now, to prove my point, let me just hover over this math module and just press Control and then hover over it. So right now I'm pressing Control and I'm hovering my mouse over this math on the PyCharm IDE, and now I'm going to click it. And when I click it, you will see this module is nothing but a file, right? And inside this module, we have a number of functions which we can use. For example, a cos function or a tan function or many different functions which we can use from this math module. So a module is nothing but a Python file. Now, if a module is nothing but a Python file, why don't we create a module? And it turns out that Python allows us to create our own modules. So let's create our own modules, and let me show you how you can create your own module. And right now you can see in my project there is only one file, which is hello.py, and it's empty right now. Now to create a module, I'm going to just create a new file. So right click and then new Python file, and this module I'm going to name it as my functions, and then press OK, and this file is created. So now I have two files in my project. One is my functions and other is hello.py. So let's say I want to create some functions inside this my functions.py file. So let's create some function. I'm going to very quickly create some very basic functions which you already know in Python. So let's say a add function which returns the addition of two numbers, and also let's create, let's say, multiply functions. So multiply, and this is going to just give the product of two numbers. So let's say this is our module and it has two functions. Now somehow I need to use these two functions from my functions.py file into this hello.py file. Now as you can see, these two files are in the same directory, right? So I can import this my functions file using import and then the name of the file, which is my functions, and that's it. So in order to import a module, you just write a keyword called import, and then you just write the name of the file without the extension py. Okay, so you don't need to provide any extension here, and then I can use this function. So let's say I want to print my function, which is the file name. So whatever file name you give here, you need to use the file name here. Dot, you will see all the functions in the file are now visible in the other file, which is hello.py. So let's use this add function, and I'm going to just give two parameters here. And also let's use the multiply function from the my functions file. So the file name and the method name or the function name, and let's give two parameters here also, and that's it. So it's that simple to create your own modules and import them into other files in Python. Now when I run this program, it's going to give me the addition and the product of these two arguments which I have provided here. Now let's say your my functions file is in some other directory. So let me create a directory. So I'm going to right click here and then I'm going to create a directory, and I'm going to name it as dir and then click OK. And now I'm going to move this my functions.py file into the new directory. So I'm going to just right click and cut from here this file, and I'm going to just paste this file into the dir directory. Okay, so let me just click OK here. And as soon as I do this, you will see here PyCharm is intelligent enough to refactor this code, and now it has given us the correct import. Okay, so if this my functions file is in some directory, then you use this type of notation. So you write from and then your directory name and then import keyword and then your file name. So you can see this is the directory name and this is the file name. So I use from directory name import file name, and when I run the code once again, it's going to give me the same answer. Now there is one more way of writing the same notation, and that is using the import. So use import keyword and then write the name of your directory dot the name of your file. So directory dot the file name, and then you use this name in place of your my function name. Okay, and once again when you run the code, it runs fine. Now sometimes you might feel that this is a long name, and Python have the solution for it also. So it turns out that you can rename your file using a keyword called as. So after the import, so import directory name dot file name as, and then you can provide your name. For example, my functions, I will just name it as mf. Okay, and now I can use this mf name instead of this big name, and this will also work fine. So either you can import from your file which is inside the directory using this notation, or you can use this notation. You can also write as in front of this notation also. So from directory name import file name as whatever name you want to give here, and this you can use to call your function using this dot notation. Now this was the easy stuff, and I have just written here the two functions and then imported these two functions into the other file. But what if I have multiple classes? I haven't shown you how to import files which have classes in them. So let's see how to import the Python files which have classes inside them. So I'm going to close these two files, and in the last video I have shown you how to use inheritance in Python, and we have created this class polygon and two other classes, which is triangle and the rectangle class, and this might be right now the perfect candidate to import into some other file. So I'm going to create two more files. One is the rectangle file. So I'm going to just right click and create a Python file, and I'm going to name it as rectangle. And I'm going to create one more file with the name of triangle. So right click, new Python file, and the name is triangle.py. And let me create the fourth file, which I'm going to name it as main. And this will be our main file in which we will import all these classes. So in my polygon class, I will just leave this polygon class, and I will just transfer this rectangle class into the rectangle.py file, and this triangle class into triangle.py file. And also this was the instantiation of the rectangle and triangle class which we have done. So I will transfer this code into our main.py file. Okay, so now we have a polygon.py file in which we have the polygon class, and then we have the rectangle class inside rectangle.py, and also we have the triangle class into the triangle.py file, and the rest of the code we have inside the main.py. Now when you go to the rectangle.py, you will see that it's inheriting from the polygon class. That means we need to import polygon class into the rectangle.py file. So how to import it? You can use from and then the file name, which is polygon, and then use import keyword and use the name of the class, which is polygon, and you will see that this error is gone. And same we will do inside the triangle.py file in order to import the polygon class into the triangle.py file. So this is the file name. So from file name, import the class name. Now when I go to the polygon class, we don't need to import anything here because it's a super class and there is no import needed here. Let's go to the main.py file, and here you will see red squiggly line under rectangle and triangle class because we haven't imported this triangle.py and the rectangle.py into our main.python file. So the procedure is same. From your file name, which is first of all rectangle, import the name of the class, which is rectangle. Same we will do for the triangle class. So from the triangle file name triangle.py, and then import and then the name of the triangle class. And you will see as soon as you do this, the error is gone. So now there is no red squiggly line under any of the code. So now let's run the code. So I'm going to just go to the main.py file, and I'm going to right click on this main.py file, and I'm going to just click on run main, which is going to run the program, and it's going to print the result, which is the area of rectangle and the area of the triangle. So in this way you can import the py file which have classes inside them. So this is how you create your own modules in Python and import them into other Python files. In this video, we will talk about multiple inheritance in Python. So first of all, what is multiple inheritance? So the ability of a class to inherit from more than one class is called multiple inheritance. And in Python, a class can inherit from more than one class. So let's see an example which shows us how to inherit from multiple classes. Now I will be using this example which I have already shown you in the video where I have shown you inheritance in Python. So there is a class called polygon, which is a superclass, and the other two classes are triangle class and the rectangle class, which are the subclasses, and these two classes are inheriting from the polygon class. And I have also one more Python file which is main.py, and in this main.py I'm just importing these two rectangle and triangle class and creating an instance out of them, and then setting the value of width and height, and then we are printing the area of the rectangle and the triangle. So if you haven't seen the last two videos, just watch those videos because I will be using the same code in order to show you how to use multiple inheritance. So let's get started. So what I'm going to do is I'm going to create a new Python file here, and I'm going to name my file as shape, and I'm going to use this shape.py to create a class called shape. So let me create a class quickly, and I'm going to name it as shape, and this method I'm going to define a private variable called color, and I'm going to initialize it with the value none, and then I'm going to define the setter and getter for this color attribute. So let's define those. So now we have defined the setter and getter for this color attribute. Now if you remember what I told you about inheritance, and that is whenever you want to do inheritance between a superclass and a subclass, there is a relationship between the subclass and the superclass. So rectangle is a shape and triangle is also a shape. So that means we can also use this shape class as the superclass in rectangle and the triangle classes. So let's use the shape class into the rectangle and triangle class as the superclass. So first of all, I'm going to import this shape class from the shape file. So let's import this, and same I will do in the triangle class also. And now how to inherit from multiple classes into our subclasses. So we have already inherited from the polygon class, and in order to add one more class here, you just need a comma separator and the name of your class. So this is how you inherit from multiple classes. You just use the parenthesis and then the name of your classes separated by the comma. That means the triangle class is inheriting from the polygon class as well as the shape class. The same we will do in the rectangle class. So I will just provide the comma here, and then I will just write shape here. And now I will go to the main.py file, and once you do the multiple inheritance, that means all the public methods of the shape class is available in the subclasses, which are triangle and the rectangle. So I can use this kind of notation. First of all, I'm going to use rectangle class to call the method called set color. So I'm going to set color from here, and let's say the rectangle color is red, and then I'm going to use the triangle object to call the set color method once again, and the color I want to provide here is, let's say, blue. Okay, and in order to get those two color values, we can once again write print the instance name, which is rectangle dot get color, and same we will do for the triangle object also. So print triangle dot get color, and that's it. So now all the public method of the shape class is also available in our rectangle and the triangle classes, and we can use all the public methods of this shape class into the subclasses. And let's run the code and let's see what happens. So the code is running, and you can see it prints red and blue using these two statements. So this is how you can do multiple inheritance in Python. In this video, I'm going to show you how you can use a built-in function called super in your Python classes. So let's get started. So to start with, I have two classes here. One is the parent class and other is the child class. And here parent class acts like a super class and the child class acts like a subclass which is inheriting from the parent class. Now both these classes have this init function, and you already know what does this init function do. It is the first function which is called when an instance of a class is created. And here I'm just creating the object from the child class. Now what do you think will happen? Will this constructor will be called, or this constructor will be called, because we are inheriting from the parent class into the child class? So let's find out. So I'm going to run this code and it prints child init. That means this statement under the child class init method is executed and this method is not executed. Now in some cases you might want to pass some parameters also into your super class. For example, I'm just going to give this example. Let's say I want to pass an argument called name here, and then I will just print the value of name. How can I call this init function using this child class instance? So it turns out that there is a function called super in Python that allows us to refer to the super class implicitly. Now this super function is a built-in function which returns a proxy object that allows you to refer to your super class. So let's try to use this super function. So you just use the keyword super and then give these parentheses because this is a function, and then this super function will return the proxy object of the super class. That means I can use this dot operator to call the init method from the super class. So this notation means super.init means we are calling the init method from the parent class, and that means we can pass the name from here. So let's just pass this name. I'm going to just write max here, and now I'm going to run this code. And now you will see that child init is printed using this statement first of all, and then using the super function the init method of the parent class is called, and then this name is passed here and it prints parent init and the name, whatever name we have provided here. So this super function allows us to refer to the super class. Now let me show you one more thing which is called the method resolution order, and you can find this method resolution order by using your class name. So child class name dot underscore underscore MRO. So just write underscore underscore MRO underscore underscore, and this statement I'm going to use inside the print function so we can see the result what it returns. So I'm going to run the code now, and you can see it returns this kind of order. So as the name suggests, MRO stands for Method Resolution Order, and this is the order in which the methods are called inside your child class or the parent class. And this order means that all the method in the child class will be executed first, and then all the method in the parent class will be executed. Now there are some rules based upon which this order is calculated, and these rules are: the first rule is the method inside your subclass are always called first, and then whatever the method inside the base class, they will be called. And the second rule is related to multiple inheritance. So let me just create the second parent class, and I'm going to name it as parent2, and here also I'm going to just write parent2 here, and let me inherit from the parent2 also in the child class, right? And let's run the code once again, and now you will see this order. So once again, child is printed, and then the parent, and then parent2, and then the object. So the second thing on which the MRO depends upon is the order in which you inherit from the parent class or the superclass. So in our example, we were inheriting from the parent class first of all, and then parent2. And in the same order, this MRO also will be decided. So all the method in the child class will be executed first, and then all the methods inside the parent class, whatever you use first here, will be executed, and then whatever superclass you write after that, those method inside the class or superclass will be executed next, and then at last this is the base object. Now let's try to just reverse this order, and once again let's run the code, and you will see that this order will be reversed. So the method resolution order will tell you which class method will be executed first, and then the order of all the methods from the superclasses. Now one more interesting thing which you will observe here is this output. So I said that this super function is used to refer to the superclass, and now we have two superclasses, that means multiple inheritance, and you will see here that only one output is printed, which is from the init method inside the parent2, and this statement is not printed, which is inside the init method inside the parent class. So how to solve this problem? So if you have multiple inheritance, then you need to manually call these init function using the class name. So let's say I want to call the init function first of all from the parent2 class. I will use parent2 dot init, and then you need to give also the self as the first parameter, and the second, which is the name. In the same way, you use the second class, which is parent dot init function, and then first parameter is the self, and then you can pass any other name, for example Tom here, and let me run the code, and you will see it calls first of all parent2 init function, and we have passed Max here as the name, and then it calls the parent1 init function with the name Tom, which is printed here also. So this is how you can use super function in Python. In this video, we will talk about operator overloading in Python. Now you might already know that everything is an object in Python. So when I want to know the type of this number 2, it's going to show this kind of output, and this means that 2 is an object of the class int. Now when I once again want to know the type of, let's say 2.0, it's an object of class float. When I want to do the same operation with the string, this string is an object of class string. So everything is an object in Python. Now have you ever wondered that when you do 2 plus 2, it's going to give us the addition of two numbers, and when I add two strings, let's say 2, and then I'm going to use the same operator, which is plus operator, with the other string. It's going to give me the concatenation of these two string values. So the same operator plus is working differently with different type of objects. The same you might have observed with the multiplication operator, which is this asterisk. So when I use this asterisk or multiplication operator with a string, and let's say I write 3 here, it's going to print this given string 3 times. But the same operator, when I will use with the two numbers, it's going to give me the different behavior, which is the multiplication of these two numbers. So the same operator asterisk is functioning differently with different kind of data. Or in other words, we can say that this asterisk operator or this plus operator are overloaded for different kind of objects. So whenever this plus operator is used with two numbers, it's going to give us the sum of these two numbers, and whenever this operator is used with the string, it's going to give us the concatenation of these two strings. So both these operators are overloaded for handling different kind of data. So this is the overloading of the built-in operators. Now we might also think that if this is possible, can we overload the operators by our custom classes? So let me create a class, and I'm going to name it as the number class, which is going to take one argument. So let me define a constructor here. So underscore underscore init underscore underscore, and this is going to take one argument, which is the number, and I'm going to just write self.num is equal to num. So this is the simple class which we have created, and now I'm going to create two instances of this same class. So number, and I'm going to give the number 1, let's say here, and then I'm going to create a second object of this class, and this time I'm going to give the number 2 here. So is it possible that we can use, let's say, n1 plus n2? So let's try this, and it's going to give us this error which says unsupported operand type for plus number and number. So because Python doesn't know how to use this plus operator with your class objects, it's going to give us this error, which is unsupported operand type and whatever is the operator you are using. So it turns out that we can overload these kind of operators in Python by implementing some inbuilt methods in our class. So we already know that whenever we want to implement a constructor in Python, we use this init method. So I'm going to create a very simple class, and I'm going to name it as A, and this will be a blank class. So this is a very simple class in Python, and when I use a dir function, which is a built-in function with this class, let's see what happens. So I'm going to just press enter, and it's going to print some methods here which are inbuilt method. So here not all methods are visible, so I'm going to assign this value of dir a to a variable a, and then we will see in the right hand side in this inspector here, and this is the a variable, and you will see the list of all the inbuilt methods which are associated or which you can implement them. So for example, we have implemented the init method in order to have the functionality similar to constructor, but there are other methods here too. So there is a str method or le method, which is less than method, or ne method, which is not equal to method, and many other methods which we can implement here in our class. So now I have given enough theory to you, and let's try to see with an example how to overload an operator in Python. So here I have created a class which I call circle, and this takes one argument, which is the radius of the circle, and I have created the setter and getter method for this radius variable. And in the third method, I'm just calculating the area of the circle using the radius, and I have also used our inbuilt module which is math in order to get the value of pi. So using this expression, I'm just calculating the area of the circle. Now I have created two objects of this class with two different radiuses. So in the first object I have given the radius 2, and in the second object I have given the radius 3. And from the theory which we have learned till now, we already know that this expression will not work with these two objects. So when I run this code, it's going to give me the error which says unsupported operand error. So now we are going to overload this plus operator in this circle class. Now in order to overload a particular operator, let's say plus, you need to implement an associated method in your class. So with this plus operator, there is a special method which we need to implement in our class, and I have given the list of all the methods which is associated with the operators. So with the plus operator, you need to implement this special method which is underscore underscore add underscore underscore. In order to overload minus, you use this method. In order to overload the multiplication, you use this method. So here is the operator which we want to overload, and here I have given the method name which you need to implement in your class in order to overload this operator in Python. So there is this list which you can use with all these operators. So you can overload the mathematical operators in Python. You can also overload the bitwise operators in Python like AND, or bitwise right shift or bitwise left shift. And also you can overload the comparison operators in Python using these associated methods with these operators. So now we want to overload this plus operator. So we will implement this add method into our class. So let's implement this add method into our class, and implementing this method is really simple. You just need to define a special method which is underscore underscore add underscore underscore, and this add method is going to take two arguments. One is self, you already know, and the other is the object of the other instance. So this second argument is the object of the circle class. And now inside this method, I'm going to just return. First of all, I will just use this circle as the constructor. And what I want to do, I want to add, let's say, the radius of the two objects which are provided. One is the self object and other is the object which is provided using this argument. So I'm going to just say self dot underscore underscore radius plus the circle object radius. So let's use this circle object and then dot and then underscore underscore radius. So basically I'm adding the radius of the two objects. One is this circle object and other is the radius of the self, which is the current class. So as soon as you implement this method add using these two arguments, then this operation is going to work in Python. So because we have overloaded the plus operator using this add method, now this operation is going to work. So let me just assign the addition of these two objects into a third variable, and this variable I'm going to name it as C3. And using this C3, let's say I want to print the radius of the circle. So I'm going to just use the print method and then I'm going to use the C3 object and I'm going to call a get radius method from this object. And let's print the radius of C1 and C2 also. So here I'm going to just write C1 and here I'm going to just write C2. So we are printing the radius of all these three objects. And I'm going to run the program now. And you can see here the radius of the first object is 2 because we have provided 2 as an argument here. The second is 3 because we have provided 3 as an argument here. And because we have created this third object using the overloading of this plus operator, where we were just adding the radius of both the objects. That's why we got 5 here. So 2 plus 3 is equal to 5. And this addition we have done using this expression. So we have added the radius of the current class and the object which is passed using this argument. So this is how you can overload the operators in Python by implementing the associated methods which are available in Python. So let's say now we want to overload the less than and the greater than operator. So for the less than operator, we use this LT method, and for the greater than operator, we use this method called GT. So let's implement these two methods inside our classes. So I'm going to just copy this add method 2 times, and first of all I'm going to replace this by LT, which is less than, and the second method I'm going to replace by GT, which is greater than. And we want to see if the radius of the circle is greater than the second radius which is provided using this object or not. So first is less than, so we are going to provide this operator, and second is greater than, so we are going to provide the other operator which is greater than operator. And now this less than and greater than function is going to give us the Boolean value. If this radius is less than this radius, then it's going to return us true, otherwise it's going to return us the false. So I already have the two instances of two classes, and if I want to compare these two classes, I can just write C1, and I will use the less than operator here, and then C2, and also I'm going to use the greater than operator here, and let's run the code and let's see what happens. So now it's going to give us this value, which is the constructor of the circle. So how can we get the Boolean value? You just need to remove this constructor from here. So you just need to remove the name of the class, and now I'm going to run the code once again, and now you will see true and false. So we were checking if C1 radius is less than C2, and it gives us true, and once again we were checking if C1 radius is greater than C2, and it has given false to us. Also we can check the third object, for example C3 here, if C3 is greater than C2 or not, and most probably it's going to give us true, and it's correct here. So you can see it's that simple to overload any operator in Python using these built-in methods. So you just need to find out the associated method related to that operator, and then you just need to implement that method related to that operator. In addition, you can also implement some other methods which are available with the class. So once again, when I'm going to print the dir with any of the object, let's say C1, and I'm going to run this program, and you can see the list of the functions which you can implement inside your class. So add is already there, but you can also implement this dict method or dir method or any of these methods which are available here. So repr method or str method, any method you can implement inside your class in order to avail the functionality associated with that method. So at last, let's try to implement one of the method which are associated with the class. So let's say we want to implement this method, which is the str method. So I'm going to just minimize this, and I'm going to just copy this function and once again paste here, and instead of greater than, I'm going to just implement now the str method. Now this str method only takes one argument, which is self, so I'm going to just remove the second argument, and here in the return value I can just return some string, for example. So I can just say circle area, and I'm going to return the area of the circle. So I'm going to use this concatenation operator, and then I'm going to convert the area into the string, and then I'm going to just use self dot area, which is going to give us the area of that circle. So once you have implemented this str method in your class, you can simply use it like this dir method. So I can just write str and then the name of your object which you have created, and let's run the code and let's see what happens. So I'm going to just see the result now, and it prints circle area and it's going to print the area of the circle. I just need to provide equals to symbol here, so we will be able to see it in a prettier way. So you can see the area of the circle is printed. Similarly, you can print the area of the other two circle, which is circle 2 and circle 3, and let's run the code once again. It's going to print us the area of all these circles. So this is how you can use operator overloading in Python. In this video, I'm going to show you what is composition and how to use class composition in Python. So to start with, I have two classes here. One is an employee class and other is the salary class. Now in the salary class, I have this init method which takes two arguments, pay and bonus, and it sets these two arguments to the member variables of this class. Also, I have a method called annual salary which is used to calculate the salary. Now in the employee class, I have this constructor which takes four arguments, which is name, age, pay and bonus. Now what do you think? Can we apply inheritance here? The answer is no, because there is no is-a relationship between salary and employee. So employee is not a salary and salary is not an employee. But somehow I want to delegate the responsibility of calculating the employee's salary to the salary class, because calculating salary is in itself is a big task. I have just simplified this class in the form of just calculating the annual salary, but the employee can have his own taxes, or he has taken some leaves, or many factors affects the salary of an employee. So this salary calculation, let's say we want to delegate to the salary class, but whose salary is this? This salary is the employee's salary. So we know that we cannot use inheritance here, but we can use a concept called composition here. And the composition means that we are just delegating some responsibility from one class to the another class. So how to delegate this responsibility? We can just create one more variable here. For example, self.obj underscore salary, which is the salary object we are going to create using the salary class. Okay, and this salary class takes two parameters. One is pay and other is bonus, which we are already providing using the employee init method. So I'm going to just pass this pay comma the bonus into the salary class. So we are instantiating the salary class inside the employee class. So here one class, which is an employee class, acts like a container of the other class, which acts like a content. Okay, so salary class is the content and the employee class is the container of this salary class. Now in order to calculate the total salary, we can define one more method here, and I'm going to just say total underscore salary, and then what we are going to do is we are going to call our object salary member variable, because this gives us the object of the salary. So I'm going to just call object salary, and we can call this method from the salary class, which gives us the annual salary. And now I'm going to just create the object of this employee class. So let me just write emp is equal to employee, which takes four parameter. First is name, second is the age, third is the pay. So let's say pay is 15,000 and the bonus is 10,000. And now I just want to print the total salary of this employee. So I can just write print and then emp object dot the total salary, which is total salary method. And you can see here this total salary is returning. Let me just use the return keyword also, because we are returning this annual salary from the salary class using this total salary method. So let's run the code once again and let's see what happens. And you can see annual salary is printed, and this annual salary is calculated using the salary class. So what this employee class has done, it has delegated some responsibility to the other class, which is the salary class, which gives us the annual salary of an employee. And this here is called composition. Now, one interesting thing which you will notice here is we are not instantiating salary here. We are just instantiating the salary inside an employee class. So as soon as you delete an instance of an employee, the salary class instance will be automatically deleted. So whenever you want to delegate some responsibility of one class to the another class, it's called composition. One more example of composition can be a book class and a chapter class. So a chapter is not a book and book is not a chapter, but we can delegate some responsibility from a book class to the chapter class. So this is how you can use composition in Python. In the last video, we have seen how to use composition between classes in Python. In this video, I'm going to show you how to use class aggregation between classes in Python. Now, if you haven't watched my last video in which I have shown you how to use class composition in Python, I will highly recommend you to watch that video, because I will be using the same code to demonstrate how aggregation works in Python. So in the last video, we have created two classes. One is an employee class and the other is the salary class. And then we have used the salary class inside the employee class, and we have seen how composition works in Python. So employee class is delegating some part of its responsibility to the salary class, and that is called the composition. Now in composition, the relationship between the classes which have some association is represented by a keyword part of. So salary is the part of employee. So the keyword we use in composition is part of. Now let's see how we can use aggregation instead of composition between these two classes. So let's say I will not use this salary class inside the employee class, but what I'm going to do is I'm going to pass an instance of salary here. So I'm going to just write salary, and this will be the object of salary class, which I'm going to pass in the init method of the employee class. So let's create an object of the salary. So I'm going to just write salary here is equal to the salary class, and we will instantiate the salary class by these two arguments which we have given in the last video to the employee class. So I'm going to just copy these two arguments and paste it here, and I'm going to remove this comma here. So now what we are doing here is we are first of all instantiating the salary class, and now the salary class we can pass to the constructor of the employee class, and this is the object which we have passed using the salary class object. And then I'm going to take this salary class object and I'm going to assign this salary class object to the member variable of the employee class, which is obj underscore salary. Now because we are passing the salary object, that means this member variable is the salary member object, and we can call any public method from the salary class using this member variable now. So let's run the code and let's see what happens. And we get the same result as we have seen in the last video in the composition example. So what we have done differently here. So instead of using this salary class inside the employee class, we have first created an instance of the salary class, and then we have passed this instance to the employee constructor, which can be used inside the employee class. And this type of relationship is called aggregation. Now let's see what are the special properties of the aggregation. The first property is the relationship between the associated classes in aggregation is defined by the keyword has a. So employee has a salary, because now we are first of all creating the salary object and then passing it to the employee. So now we are not directly using salary inside the employee class. The second property of aggregation is the associated classes have unidirectional association. So we are just passing salary object to the employee class. We are not passing employee object to the salary class. So it's a unidirectional association. Only salary can be passed to employee, not the other way around. And the third property of aggregation is we have created the salary object and the employee object. So both these objects are independent of each other. So if one object dies, the other survives. So both the objects are able to survive individually. So these are the three properties of aggregation. Now let's see the difference between the composition and the aggregation. So I'm going to split the screen. So I'm going to just right click on this tab and I will say split vertically. And here I'm going to open the example of the composition. So on the right hand side I have the example of composition, and on the left hand side I have the example of aggregation. Let me just maximize this so you can see it. And now let's discuss about the differences between the composition and aggregation. So the relationship in composition is defined by a keyword called part of. So salary is the part of employee. In aggregation, there is no part of relationship, but the relationship is defined by the keyword called has a. So now in aggregation, we are defining the instance of salary and then passing it to the employee class. And salary is not the part of the employee class. We are just passing it to the employee class. So aggregation, we use has a relationship, and in composition, we use part of relationship. The second difference is when you delete the employee object, the salary object will be automatically be deleted. So salary object is dependent on the employee class. But in aggregation, the salary object and the employee object are individually independent. So they can survive individually. If one object dies, then it doesn't matter that the other object dies, because we have created these objects individually. Now in composition, both salary and employee are interdependent on each other. But in aggregation, the relationship is unidirectional. So the association between the employee and the salary object is unidirectional. We can only pass the salary to the employee class, but we cannot pass the employee object to the salary class. So these are the three major differences between composition and the aggregation. In this video, we will talk about creating abstract classes in Python. So let's get started. So to start with, I have here two classes. One is a shape class, another is a square class. In shape class, I have two empty methods. One is area and other is perimeter. And I'm using shape as a superclass and square as a subclass, and square class is inheriting from the shape class. Now in this example, I want to do two things. One is I don't want to allow the other users to create an instance of a shape class, because shape class acts like a template for the square class. So I don't want to allow the users to create an instance of this shape class. So let's see right now if we can create an instance of this shape class or not. So I'm going to just write shape is equal to shape, and when I run the code, my code runs fine. That means right now I'm able to create an instance of the shape class, which I don't want. The second thing is I want to make sure that both these methods which are there inside the shape class are implemented inside the square class. So I want to make sure that whoever is using this shape class, he or she must implement these two methods inside the subclass. So how can I achieve these two things? Now it turns out that abstract classes are just made for that. So how to create an abstract class in Python? The fact is, Python on its own doesn't provide any abstract class. But don't worry, there is a built-in module in Python which we can use to create an abstract class. So let's import this built-in module first. So I'm going to just write from ABC import capital ABC, comma, abstract method. So these are the two things we need to import from this module. Now this module ABC stands for abstract base classes, and this allows us to create the abstract classes. So how we can create an abstract class using this ABC module? So what we need to do here is we need to inherit from the ABC module into the shape class. Okay, so shape class is inheriting from the ABC module. Now once this shape class inherit from the ABC module, the second thing what we need to do here is we need to add a decorator here. And how to add a decorator? We just need to use @ and then the name of this abstract method, which is like this. And let me use this abstract method decorator on top of this parameter method also. So what this abstract method decorator does is it makes these two methods abstract. And what is an abstract method? An abstract method is a method which you must implement in the subclass. So when you run the code now, it will give us this error which says can't instantiate abstract class shape with the abstract method. So once you create any of your class method as abstract, then your class becomes the abstract class, and then you cannot instantiate this class like this. So our first goal is achieved, that we cannot instantiate this shape class now because this class is now an abstract class. And how to create an abstract class? You just need to import the ABC module, and then you just need to add this decorator on top of your method. And if you do this even with one method in your class, then your class becomes abstract. So now we have removed the instantiation of this shape class. But now when I try to instantiate this square object from the square class, let's see what happens. So this square class takes one argument, which is the side of the square. And let me run this code. And once again, it gives us an error. And this error says can't instantiate abstract class square with abstract methods. So that means that whenever you inherit from a class which is an abstract class, and if this class contain any abstract methods, then the subclass have to implement the methods which are abstract. So this method area is an abstract method, and this method parameter is also an abstract method. That means we have to provide the implementation of these two methods inside our subclass. So I'm going to provide the implementation of area first of all into the subclass, and area I'm going to just return as the multiplication of the sides, right? So self dot underscore underscore side multiplied by itself. So self dot underscore underscore side. And let's say for now I will remove this abstract decorator from the parameter method, and let's run the code once again, and you can see it runs fine. So there is no error when we instantiate this class when we implement all the abstract method into your subclass. So right now there is only one abstract method, which is area into the shape class, which we need to implement in the subclass, and that we have done, so we see no error here. Now let's add this decorator abstract method on top of this parameter method also, and once again when I run the code, it will give me once again this error, and it's going to give me the same error which says can't instantiate the abstract class square with the abstract method perimeter. So we also need now to implement this method also. So let's just implement this perimeter method inside the subclass once again. And what is the perimeter? It's 4 times the size of your square. So self dot underscore underscore size, and now we have implemented both of them, and once again when we run the code, it runs fine. Let's also try to print the area and perimeter of the square. So I'm going to just use this object to call the area method, and in the next line I'm going to just use print to once again call this object, and this time I will call the perimeter method. And let's run the code once again, and it prints the area of the square and the perimeter of this square. So let's rewind what we have learned till now. So in Python, you can define an abstract class by importing this module and this abstract method, and this ABC stands for abstract base classes, and you need to inherit from this ABC into the class which you want to make abstract. The second thing which you need to do is you need to provide this decorator @abstract method on top of at least one of the methods inside your abstract class that makes your class abstract. And what are the properties of the abstract class? You cannot instantiate an abstract class, so you cannot create an object of this abstract class, and you need to implement all the abstract method into the subclass which is inheriting the abstract class. So this abstract class acts like just a template for other classes which wants to inherit from this shape class. So this is how you can use abstract classes in Python. I hope you have enjoyed this video, and I will see you in the next video.